Okay, good morning and Assalamu alaikum. Let's get started. Attendance: Sharajit Shutrudhar, Faya Shibli, Farhan Ishraq, Asif Mahmood.
Did you say Tasin Mahmood?
No, not yet. Asif Mahmood. Shamrat Khan, Sanjana Rakib,
Present, sir.
Mujahidul Islam,
Present, sir.
Sabrina Jahan,
Present, sir.
Amarul Islam, Maruf Ahmed,
Sir, Asif Mahmood Shakil is present, sir. Thank you, sir.
Amarul Islam, Maruf Ahmed Siam, Shams Noor, Ishtiaq Ahmed, Sayyid Nouri Manik, Farhan Soberin,
Present, sir.
Yasir Arafat, Hasanul Kareem,
Yes, sir.
Mushfiq Islami,
Present, sir.
Noor Kainat, Ishraq Zohair, Simon Akhtar,
Present, sir.
Shamsul Adnan,
Present, sir.
Abdul Muqeet,
Present, sir.
Imtiazuddin is present. Naimur Rahman,
Present, sir.
Tosif Elahi,
Present, sir.
Simon Mahmood,
Present, sir.
Bushra Jannat,
Present, sir.
Faiza Tabassum, present. Asif Al Masood,
Present, sir.
Mahfouza Khanam, Tasin Mahmood is present. Krishna Chandra Mollik,
Present, sir.
Pratik Shah, Pratik Hassan,
Yes, sir.
Raqibul Islam,
Present, sir.
Tasmin Zareen.
Present, sir.
You have been absent for many classes. Abhishek Shekdar,
Present, sir.
Awir Hassan, Jaima Jahan,
Present, sir. Present, sir.
yeah, okay. Sajid Hussain,
Present, sir.
Mubashir Zaman,
Yes, sir.
Nafisa Rahman,
Yes, sir.
Fabiha Rahman, Fariza Rahman,
Present, sir.
Samrin Chaudhary, Hassan Imam,
Present, sir.
Shamsal Abrar,
Present, sir.
Sadia Jui,
Present, sir.
and Nur Rafi.
Present, sir.
Fabio is not present.
Sir, Abir Hassan present.
So number 1, Sardis Shukladar.
Hello.
Nur Rakib,
Present, sir.
So number 1, Sardis Shukladar, sir.
did Fabiha
Sir,
say
Abir
that?
Hassan.
Sir, Fabio is not present.
Sir, Shamsu, 192.10.
So Sardis Shukladar, sir.
Okay, let's move. Sanjana, how is your family? Sanjana,
Doing better, sir.
is your father well?
Yeah.
Is he in the hospital or at home?
He's at home.
তুমি ভালো আছো?
Yes, sir. So far, I've been good.
Okay. All right. Okay. Today we are going to look into some solved problems on the continuous distribution. We will finish this today, and the plan is to have a classwork next week on Thursday. We have 4 more classes after today's class. We'll use them for the 2 topics that is left. Sampling and estimation, and regression. We need 1 class. Generally, we need 1 class for regression, and 3 classes for sampling and estimation should be fine. So you're actually quite fine actually. So let's actually move forward. Solve problems on continuous distribution. Suppose that fx is 1.5x squared from x from -1 to 1. This is a possible distribution, and determine the following probabilities. Okay, so this is the probability distribution from -1 to 1, and the problem does not say that show that this is a valid probability distribution. If you had to show that this is a valid probability distribution, you have to show that 2 things: fx is greater than 0, and in 2, integration alpha to beta, in fact, negative infinity to infinity. Negative infinity to infinity fx dx would be equal to 1. If the problem had asked you to show that this is a valid probability distribution, then essentially you needed to show that. So anyways, we can see that fx is greater than 0 because all values are positive here, and integration would be 1. If you perform the integration, it would be equal to 1. So these 2 properties are valid. So anyways, probability is 0 less than x. So which area is this? Zero less than x. Which area is this? This is 0.
Left side, sir.
Left side. 0 less than x means
Right side, sir.
right side, x greater than 0. Okay, so we are looking into area on the right. So 0 to infinity. In fact, this will be 0 to 1, and half. So as you can see that, as I was discussing before this problem, the area on the right is half. Okay, area on the right is half, which means that the area on the left will also be half, which means that the total area is 1. Anyways, once again, 0.5 less than x greater than 0.5, 7 by 16. Between negative 0.5 and 0.5, it will be 2 times of 7 by 16, 1 by 8. Sorry, not 2 times 7 by 16. X cubed by, anyways, it's going to be 1 by 8. Okay. X less than negative half, negative 2. function does not exist. The function is between -1 and 1. Therefore, the function does not exist for x less than -2. Therefore, the probability will be 0. Okay. X less than 0 or greater than -half. X less than 0, which means this portion, or greater than -half, which means this portion. Therefore, if you add the two, what probability do you get? Or if you add the two probabilities, what do you get?
1. So 1.
1. You'll be getting 1. The given domain, x less than 0 or x greater than 0.5 is the entire domain, -1 to 1. Therefore, the probability is 1. Determine x such that x less than x is 0.05, which means that I need to find some x such that this area is 0.05. Oh, sorry. This area. (0.05). Okay. I think I made a mistake here. Correct this mistake. Okay, the thickness of photoresist applied to wafers in semiconductor manufacturing at a particular location on the wafer is uniformly distributed between 0.205 and 0.2150 micrometers. Determine the cumulative probability distribution. So this is uniform distribution, alpha and beta. Okay, and so fx is 1 divided by 0.2150 minus 0.2050. The cumulative distribution from our early discussion, it's 0 for x less than 2050 and 100 into 0.2150 minus x and 1 for x greater than 2150. The distribution is like this: 0.2150, 2050. It's uniform between the two. So, and fx is, anyways, okay. Determine the proportion of wafer that exceeds 0.2150 micrometer in the photoresist. Therefore, 2150, what proportion is more than 2150? The cumulative distribution, we can find that 25% of the wafer. Therefore, from 0.2150, we substitute from the cumulative distribution we found in the last problem, we find that probability 0.25. Therefore, 25% of the photoresist is we put 0.2150 here. We will get fx to be equal to 0.75 and 2150. Okay. What thickness is exceeded by 10% of the wafer? Once again, we have to find x such that probability x greater than x is 0.1. Again, the cumulative distribution, 100 into point. We use this And we get x to be equal to 0.2060 micrometers. Determine the mean and the variance. The mean is alpha plus beta divided by 2. The mean is sorry for these. Corrections. And the variance of the uniform distribution is beta minus alpha whole square divided by 2. Therefore, the sigma square is that. The time between arrival of taxis at a very busy intersection is exponentially distributed with a mean of 10 minutes. Okay. What is the probability that you wait longer than 1 hour for a taxi? So once again, you have to determine whether you need to figure out the area on the right or the area on the left. Uniform distribution. Okay. And the beta is 10 minutes. So you have to wait for longer than 1 hour. 60 minutes. So which area? Right or left?
Sir, right.
Right. Okay. And the area on the right is 0.025. Suppose that you have already been waiting for 1 hour. What is the probability that the one taxi arrives within next 10 minutes? So what is this? This is the measureless property. Okay. So you have been waiting for 60 minutes, but it doesn't matter. Your time starts now. Therefore, you will be looking for one that within the next 10 minutes. Okay. So you'll be looking for the area on the left, F10, and 0.6321. Determine x such that the probability that you wait for more than x minutes is 0.1. You have to find x as the probability x greater than capital X is 0.1. Therefore, you get x to be 23 minutes. The lifetime of a mechanical assembly in a vibration test is exponentially distributed with a mean of 400 hours. What is the probability that an assembly on test fails in less than 100 hours? Area on the left. The mean is 400 hours. Area on the left is 0.2212. What is the probability the assembly operates for more than 500 hours before failure? Area on the right. Right of 500. 0.2865. If the assembly has been in test for 400 hours without failure, what is the probability of failure next 100 hours? Okay, once again, measureless property. Failure within the next 100 hours, probably area on the left of 100, 0.2210. If 10 assemblies are tested, what is the probability that at least one fails in less than 100 hours? Which distribution would this be? What will this be? 10 assemblies have been tested. What is the probability that at least one fails in less than 100 hours? This is a binomial distribution. Okay, and it's 10. Binomial distribution, I think I have. The problem is combination of exponential distribution, binomial distribution. So PE for the binomial distribution will come from exponential distribution that it fails in less than 100 hours, and we have found that to be P equal to 0.2212. Binomial P. and comes to 0.9179. If 10 assemblies are tested, what is the probability that all have failed by 800 hours? Same assemblies fail independently, binomial distribution, and once again, this is the probability P for binomial P.8647. If 10 units are tested, all to fail within next 800 hours, comes to 0.2336 binomial probability. Compressive strength of samples of cement can be modeled by a normal distribution with a mean of 6,000 kilogram per square centimeter and a standard deviation of 100 kilogram per square centimeter. So this is normal distribution. Mean is 6,000 kilo, and the standard deviation is 100 kilogram per square centimeter. And I think, if I'm not mistaken, I think this is called 6,000 megapascal or whatever. Pascal, I think. Newton per meter square. This is Pascal. What is the probability the sample strength is less than 6250 kilogram per centimeter square? Normal distribution mu 6 kilogram, mu 6,000, sigma 100. Go from X to Z. Z less than 2.5, and from the normal table, it will come out to be 0.9938. What is the probability sample strength between 5,800 and 5,900? Find the Z values for 5,800, 5,900. It comes to -2 and -1, and the probability is 0.1359. Is everyone following? The class has been quite. Is everyone following? This is pretty straightforward. Follow, Mushfiq.
স্যার মানে স্লো পেসে গেলে ধরতে একটু সুবিধা হতো।
হ্যাঁ, আবার বলো।
স্যার স্লো পেসে গেলে না ধরতে একটু সুবিধা হতো।
স্লো পেসে, আচ্ছা, কথাটা এতক্ষণ পরে বলতেছে কেন? আমি তো প্রায় শেষের দিকে চলে আসছি। ওকে, ঠিক আছে। So this is a problem of normal distribution. Okay, compressive strength of cement. Mean দেওয়া আছে 6,000 kilogram per square centimeter. Compressive strength বলতে কি বোঝায় জান? এটা তো আমি জিজ্ঞেস করিনি। What is meant by compressive strength? হ্যাঁ, সিমেন্টের compressive strength বলতে কি বোঝায়? কি বোঝায়? এটা অঙ্ক করে গেলাম, এই টার্মগুলো তো তোমাদেরকে বুঝাই। হ্যাঁ, আর কেউ একজন বলো না, ভুল বলো, সমস্যা তো নাই। ইশতিয়াক, Sajid?
It's like the maximum force material can handle under compression before breakage.
What? Okay, great. Okay. The other thing that I think it's worth noting is concrete is very weak in tension, but very strong in compression. It can take a lot of compressive strength, but it cannot take any tensile strength. এই জন্য যখন ঢালাই দেওয়া হয় কংক্রিটের ভিতরে, এই জন্য রড দেওয়া হয়, স্টিল রড দেওয়া হয়, যাতে টেনশনটা নিতে পারে। কংক্রিট যে সমস্ত জায়গায় টেনশনে থাকবে, ওই সমস্ত জায়গায় রড দেওয়া হয় ভিতরে। ওকে, আর so compressive strength of concrete is one of the major thing that is considered by civil engineers. 6,000 Pascal, kilogram per centimeter square, is a good strength. এবং এটা ডিপেন্ড করে কংক্রিট কি জিনিস, এই টার্মগুলো জেনে নেওয়াটা ভালো। What is concrete? বুঝলা কংক্রিট কি জিনিস? স্যার জানি, কিন্তু স্যার এটা তো ডিফাইন করতে পারবো না, তাই না? concrete. Technically, আমরা in terms of engineering, this is a mixture
With cement.
of sand, cement. এই দুটো তো আমরা জানি, কিন্তু বাংলায় যেটাকে আমরা খোয়া বলি সেটাকে ইংলিশে কি বলা হয়? হ্যাঁ, and aggregate বলে, and gravel, aggregate mixture. বিভিন্ন রেশিওতে মিক্স করা হয় এগুলো, এটা কোনো ফিক্স কোনো ইয়ে নেই। 4:1:1 অনেক অনেক রেশিও হতে পারে, 6:7 ডিপেন্ড করে এটা কি কাজে ব্যবহার হচ্ছে, নর্মাল ফিলিং এর কাজে ব্যবহার হচ্ছে নাকি বিমের কাজে ব্যবহার হচ্ছে নাকি রুফের কাজে ব্যবহার হচ্ছে নাকি কলমের কাজে ব্যবহার হচ্ছে, তো বিভিন্ন রেশিওর মিক্সচারে করা হয়। এনিওয়েজ, তো 6,000 6,000 kilogram per centimeter square, and standard deviation. So this is the mean. This is normal distribution. Mean mu and standard deviation sigma. So আমি যদি normal distribution the plot করতাম 6,000 and standard deviation 100. So what is the probability? It is less than 6,250. So somewhere 6,250. বাঁদিকের এরিয়া আমাকে বের করতে বলা হয়েছে। তো mean is this 6,250 z less than 0.9938. Z less than 0.9938. Z less than 2.5. Z less than 2.5, we'll take the same like 0.9938. এই ভ্যালুটা তারপরে Z between 5800 and 5900. So once again, x থেকে z এ চলে যাব, -2 থেকে -1. So -2 তে -2 থেকে -1, তাহলে -1 এ 0.1587, -2 তে 0.0228, 0.1587, 0.1587 minus 0.0228, 0.1357. What strength is exceeded by 95% of the sample? তাহলে আমার x বের করতে হবে such that probability x less than x will be 0.95. So I need to find a value of x such that this area is 0.95. So প্রথম কাজ যেটা আমাকে করতে হবে সেটা হচ্ছে যে নরমাল টেবিল থেকে I need to find an area of 0.95. So 0.95 এরিয়াটা কোথায়? Approximately যেখানে আছে 0.95, 1.65 approximately, 65 অথবা 645 এর মাঝামাঝি। But 645, so it comes to point, এটাকে যদি z কে যদি এখন আমি x এ কনভার্ট করি, এই রিলেশনশিপটা কোত্থেকে আসছে এটা বুঝতে পারছো? এটা where did that relationship come from? X equal to mu plus sigma z. এখান থেকে আসছে এখান থেকে you get if you cross multiply you get x minus mu equal to sigma and x equal to sigma z plus mu. Hits on a high volume website are assumed to follow Poisson distribution with a mean of 10,000 per day. Approximate the following probability. Probability that more than 20,000 hits a day. Okay? এই প্রবলেমটা এখানে নিয়ে আসার ইয়ে হচ্ছে যে we will use normal approximation of binomial distribution. Normal approximation of binomial distribution of Poisson distribution. Okay, so more than 20,000 hits. Well, as you can understand, for more than 20,000 hits, money আমাকে Poisson distribution যদি follow করতে হয়, we'll be using. It's not possible. Factorial 20,000 and factorial 20,001 and কোথায় stop করবো, we don't know. We'll use normal approximate binomial distribution, mean 10,000, sigma 10,000, and z less greater than 20,000 minus x greater than 20,000, z greater than 20,000 minus there's that 0.1 is 0.1587. কারো কোনো প্রশ্ন এখানে? Or am I moving too fast? Okay, probability of less than 9,900 hits a day. Once again, we will use normal approximation, mean that, sigma that, x less than 9,000, 0.4602. Values such that the probability number of hits exceed 0.01. Okay, আমাকে x এর ভ্যালু বের করতে হবে. Probability z greater than some z is 0.01, and from the normal table we get z to be 0.01 means area on the left will be 0.99. So once again, I come here and I find out 0.99, 2.3334, something like that. 0.123, yeah. Okay, 2.33, 2.30, 31, 32, 33. And that comes to 33,300. Approximately the expected number of days in a year that exceed 10,200. এটা কি হবে? এটা কি হবে? Approximate the expected number of days in a year, 365 days, that the number of hits to the website will exceed 10,200 hits. Expected number of days, তার মানে কি? আমাকে মিন বের করতে হবে। ওকে, তাহলে কোনো একদিন 10,200 বেশি হবে না কম হবে, এটা কোন ডিস্ট্রিবিউশন হবে? এটা which distribution would this be? Well, I find the probability that it exceeds 10,200. এটা আমি Poisson distribution দিয়ে বের করব। ওকে, কিন্তু এটা 10,200 বেশি হবে না কম হবে, এটা কোন ডিস্ট্রিবিউশন হবে? That would be binomial distribution. Okay, so this is a two-part problem. The first part, we approximate probability x greater than 2. Okay, then we will approximate the number of days, 10,200 per day. So প্রথম পার্টে হচ্ছে probability that the hit will be number of hits will be greater than 10,200.4920. The second part is a binomial problem. Recalling that the mean of binomial distribution is NP, therefore the expected number of days in a year is approximately 180 days. That the number of hits will be more than 10,200. And lecture part 4, but let's interdistribution, uniform distribution, exponential distribution, and normal distribution. They problems should not be very difficult. The percentage of people exposed to bacteria who become ill is 20%. Assume that people are independent. Assume that 1,000 people are exposed to the bacteria, approximate the following. The probability that more than 225 people become ill. এটা কিভাবে করব? কেউ একজন সাজেশন দাও। বলা আছে the percentage of people exposed to a bacteria who become ill is 20%. Assume that people are independent. Assume that 1,000 people are exposed to the bacteria. Approximate each of the following. More than 225 people will become ill. If you are exposed to the bacteria, the probability that you will become ill is 20% or 0.2. 1,000 people have been exposed. 225 জনের বেশি অসুস্থ হবে. What is the probability? কোন distribution হবে এটা?
Normal distribution.
Normal distribution এর তাহলে মিনটা কি হবে? Normal distribution তো mean আর standard deviation দেওয়া থাকতে হবে। নিচে দিয়ে দেখা যাচ্ছে প্রবলেমটা। So this will be actually a binomial distribution. Binomial distribution. Okay. N is 1,000. P is 0.2. And X is greater than or equal to 225. So এই অঙ্কটাকে binomial দিয়ে করা কি is it possible? Or is it possible? তো অবশ্যই, but is it feasible? Is it feasible? না, এটা binomial দিয়ে করাটা feasible হবে না, কারণ greater than 220 প্রথম হচ্ছে যে এই এত বড় বড় নাম্বার ফ্যাক্টোরিয়াল নিতে হবে আমাকে। Therefore, I will not be able to do that. Possible, but not feasible. Therefore, we will do normal approximation of binomial distribution. Binomial distribution. Distribution. Mu is NP, 1,000 times 0.2, 200, and sigma will be square root of N P into 1 minus P. Somebody has a question? 1,000 into 0.2 into 0.8, whatever it is. I don't have a calculator. 0.8, you calculate this, and then you do a normal distribution. 225. I need to find the area on that. Right. Mu is this, and whatever sigma you find. Okay, I think somebody had a question. Let's see. The board is unable to open. তোমরা বোর্ড দেখতে পাচ্ছ না?
Yes, sir.
বুশরা, তুমি বোর্ড দেখতে পাচ্ছ না?
স্যার বোর্ড ওপেন হচ্ছিল না।
এখন দেখতে পাচ্ছ? এখন দেখতে পাচ্ছ?
ইয়েস স্যার।
Okay. So this problem is normal approximation of binomial distribution. এই প্রবলেমটা আমরা একটু আগে করলাম। So this is normal approximation of Poisson distribution, normal approximation of binomial distribution. A supplier ships a lot of 1,000 electrical connectors. A sample of 25 is selected at random without replacement. Okay, assume that the lot contains 100 defective connectors. Using binomial approximation, what is the probability? Using normal approximation. Actually, probability কোন distribution হবে 5.70. দেখাতো একটা কানেক্টর পাঠানো হয়েছে যেটা ভিতরে 100টা ডিফেক্টিভ কানেক্টর আছে। আমি 25টা randomly select করেছি without replacement. Okay, without replacement. কোন distribution হবে এটা?
It's a hypergeometric.
This is a problem of hypergeometric distribution. এই জন্য প্রথম পার্টে বলা হয়েছে যে ইউজ নর্মাল binomial approximation. কারণ যেহেতু আমি উইদাউট রিপ্লেসমেন্ট আমি স্যাম্পলিং করতেছি 25টা, একটা যখন আমি তুলে ফেলবো এবং প্রথমে ডিফেক্টিভের probability is n is 1,000. R is 100. Okay, size of lot. Number of defective. N is 25. Size of sample. তাহলে আমি যে 25টা তুলতেছি আমি প্রথমটা আমি যখন তুলবো what is the probability of a defective item? What is the probability of a defective item? প্রথমটা আমি যখন তুলতেছি 100 divided by 1000. Okay, কিন্তু সেকেন্ডটা যখন আমি তুলবো first selection, the second selection যখন আমি তুলবো probability of defective in second selection will be 99 divided by 999. Okay, second selection. So এই জন্য এটা binomial distribution এটা হবে না, এই জন্য বলা হয়েছে যে binomial approximation যে করতে, তার মানে p equal to 0.1 ধরে অঙ্কটা করতে বলা হয়েছে। তারপরে নর্মাল approximation দিয়ে করতে বলা হয়েছে। Anyways, সবই আমরা normal distribution অঙ্ক। The diameter of a dot produced on a printer is normally distributed with a mean of 0.002 inch standard deviation. There, what is the probability diameter exceeds 0.0026? Okay, normal distribution area on the right, 0.0014 or 0.0026 in the মাঝখানের area. Okay, if 3 So anyways, এগুলো সব এগুলো মিক্স এগুলো, এবং লাস্টের দিকে কিছু অঙ্ক আছে এগুলো যেখানে আমাদেরকে ডিসক্রিট ডিস্ট্রিবিউশন নিয়ে আসতে হবে, যেগুলো আমরা দেখলাম আমরা। ওকে, তো এই অঙ্ক এগুলো করে ফেলা এগুলো।
স্যার
So is that?
স্যার মুশফিক
বলো।
স্যার, এই যে আমাদের এই যে সামনের যে ক্লাস ওয়ার্কটা হবে সেটাতে কি আমাদের কি এরকম মিক্স প্রবলেম থাকবে, নাকি ওই যে আমরা লেকচার 5 এর যে তিনটা করলাম সেই তিনটা থেকে
মিক্স প্রবলেম মানে
এই যে যে ইয়েগুলা বাইনোমিয়াল ডিস্ট্রিবিউশন আসছে, তারপরে হাইপারজিওমেট্রিক প্রবলেম গুলো আসছে, এরকম গুলো মিক্স থাকবে, নাকি ওই যে আমরা যে এই যে লাস্ট তিনটা করলাম
যেরকম অঙ্ক ক্লাসে করিয়েছো ওরকম অঙ্কই থাকবে, বুঝতে পারছো? তার মানে বেসিক্যালি যেটা তুমি বুঝতে পারতো স্যার, যেটা আমি বলতেছি না, সেটা হচ্ছে যে কন্টিনিউয়াস ডিস্ট্রিবিউশন অঙ্ক করার জন্য ডিসক্রিট ডিস্ট্রিবিউশনও মনে রাখতে হবে। আর দিস শুড নট বি অ্যান ইস্যু উইথ ইউ, কারণ তোমার সামনে তো তোমার পুরো লেকচারে করা থাকবে। এখন ব্যাপারটা হচ্ছে যে তোমাকে ডিফিকাল্টি যেটা হবে যে ধরতে হবে কোন ডিস্ট্রিবিউশন এটা, সেটাই হচ্ছে ওকে। ওকে, তো অঙ্ক ক্লাসের মতোই থাকবে, যেগুলো ক্লাসে যে ধরনের অঙ্ক করিয়েছি এরকমই থাকবে। এবং হ্যাঁ, আমি এটা অস্বীকার করবো না, ক্লাসে যে ধরনের অঙ্ক করিয়েছি এগুলো নেহাত সোজা না, একটু বুঝতে হয় আর কি একটু। ওকে, সো I will not try to fool you যে না এগুলো সব সোজা অঙ্ক। ওকে, tensile strength model by normal distribution sample সবই আমরা করেছি আমরা এগুলো। যাক, এগুলো সবই করা আছে এগুলো আমাদের। আচ্ছা, একটা জিনিস একটু করে নিই তোমাদের। আচ্ছা, মনে আছে তো ইয়ে করেছিলাম, exponential distribution and Poisson distribution? And Poisson distribution যে দুটো যে রিলেটেড, এটা মনে আছে বলেছিলাম? মনে আছে দুটো যে বলেছিলাম যে দুটো রিলেটেড? If event rate is Poisson, inter-event delay is exponential, and vice versa. If inter-event delay is exponential, then event rate is Poisson. Okay, so now let's look into this. Assume that the flaws along a magnetic tape follow a Poisson distribution with a mean of 0.2 flaw per meter. Let x denote the distance between two successive flaws. সবাই আমার সাথে আছো?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
একটু ফলো করবা। প্রবলেমটা ইন্ট্রোডিউস করেছে কোন ডিস্ট্রিবিউশন? Assume that the flows along a magnetic tape follow a Poisson distribution with a mean of 0.2 flaw per meter. ঠিক আছে, কোন কোন ডিস্ট্রিবিউশন ইন্ট্রোডিউস করেছে এখানে? This is not a trick question, this is a straightforward question. বলা আছে কোন ডিস্ট্রিবিউশন? Somebody can বলো Poisson distribution. Let x denote the distance between two successive flaws. তাহলে x এর ডিস্ট্রিবিউশন কি হবে? Let x denote the distance between two successive flaws. Then what is the distribution of x? .44 Poisson distribution. Lambda equal to not lambda 0.2, not lambda but rather mu. Flaw per meter. So x is the distance between two flaws. And x are the number of flaws in a meter. Is this the same? Are we talking about the same problem? Bushra?
No, sir. Maybe geometric.
না, কি বলেছিলাম এর আগে? এর আগের স্লাইডে কি বলেছিলাম?
Exponential.
Huh? Who is that? Okay, who answered that?
Sir, Samrin.
Samrin, yeah, great. যেটা বলা হচ্ছে যে আমার ইভেন্ট রেট যদি পয়সান হয়, যেখানে বলা আছে যে ইভেন্ট রেট ইজ পয়সান 0.2 ফ্লো পার মিটার। ইভেন্ট রেট যদি পয়সান হয়, দুটো ইভেন্টের মাঝখানে ডিলে or distance will be exponential. এখানে আমাকে বলা হচ্ছে যে আমার ফ্লো পয়সন ডিস্ট্রিবিউশন ফলো করে। ওকে, প্রতি মিটারে 0.2 ফ্লো থাকবে অন এন অ্যাভারেজ। এখন এক্স আমি একটা র্যান্ডম ভেরিয়েবল বলেছি, ডিস্টেন্স বিটুইন টু ফ্লস, ডিস্টেন্স বিটুইন টু ফ্লস। তো ইভেন্ট রেট যদি পয়সন হয় তাহলে ডিস্টেন্সটা কি হবে? কি বুঝালাম রে ইশতিয়াক?
Yes, sir.
ইভেন্ট রেট যদি পয়সন হয় তাহলে দুটো ইভেন্টের মাঝখানে ডিস্টেন্সের ডিস্ট্রিবিউশনটা কি হবে?
Sir, exponential.
Exponential. Okay, so this is a very obviously this is the last problem of the section. Obviously a tricky problemটা introduce করেছে Poisson distribution কিন্তু অঙ্ক চেয়েছে আমার mixture of exponential and Poisson. So what is the mean of x? Mean of x will be 1 by beta, 1 by 0.2. এখন তোমার এখানে যেটা থাকতে হবে, যেটা তোমার এখানে বুঝতে হবে যে অঙ্ক আমার কি Poisson distribution করতে হবে নাকি exponential distribution করতে হবে? And to understand that, you need to ask yourself the question that is it asking for the probability of the event or the probability of the delay? Okay, so what is the probability that there are no flaws in 10 consecutive meters of the tape? Is this an event probability or delay probability?
For event.
Event probability. So which distribution? If it's event,
Sir, Poisson.
Poisson distribution. Does your answer change if the answer not consecutive? Yes, it does. Okay, it's a different story. How many meters of tape needed to be inspected so that the probability at least one flaw is found is 0.9? কিসের probability চেয়েছে? ইভেন্টের probability চেয়েছে নাকি ডিস্টেন্সের?
স্যার ডিস্টেন্স।
ডিস্টেন্স। তাহলে কোন ডিস্ট্রিবিউশন হবে এটা?
Exponential.
Exponential distribution. What is the probability that the first time the distance between two floors exceed 8 meters is the fifth floor? পঞ্চম ফ্লোরতে গিয়ে the distance will exceed 8 meters. So এটা হবে দুইটা পার্টে। প্রথম পার্টে আমাকে find the probability that the distance exceeds distance is less than 8 meter. Okay, distance is less than 8 meter. এটা কোন distribution হবে?
নেগেটিভ বাইনোমিয়াল।
না, ওটা পরের কথা। কিন্তু প্রথমে হচ্ছে যে ফিফথ ফ্লোরতে গিয়ে বলা হচ্ছে যে ফিফথ ফ্লোরতে গিয়ে আমার ডিস্টেন্স 8 মিটার এক্সিড করবে। তার মানে তার ফিফথ ফ্লোর আগে কি হয়েছে? ডিস্টেন্স 8 মিটারের কম ছিল। ওকে, তাহলে ডিস্টেন্স 8 মিটারের কম হবে, এই প্রবাবিলিটি এটা কি এক্সপোনেনশিয়াল হবে না পয়সন হবে? এটা এক্সপোনেনশিয়াল ডিস্ট্রিবিউশন হবে। ওকে, তারপরে ফিফথ ফ্লোর এটা জিওমেট্রিক ডিস্ট্রিবিউশন হবে। F tau geometric distribution. It's a pretty involved problem. The time between calls to a corporate office is exponentially distributed with a mean of 10 minutes. What is the probability that there are more than 3 calls in 1/2 hour? Problem introduced করেছে the time between 2 calls at a corporate office with a mean of 10 minutes. What is the probability that there are more than 3 calls in 1/2 hour? কিসের probability চেয়েছে? টাইমের probability চেয়েছে নাকি ইভেন্টের probability চেয়েছে?
Event.
Event. So then, which distribution?
Poisson.
Poisson distribution. Beta চেয়েছে no calls in 1/2 hour. Poisson distribution. Okay. So like this, এখানে problems mix করা আছে, that একই ভাবে এখানেও এটা বোধহয় আমরা করেছি, বোধহয় এটা করেছি। The distance between major cracks on a highway follow an exponential distribution with a mean of 5 miles. What is the probability that there are no major cracks in 10 miles stretch? Problem দিয়েছে exponential distribution প্রশ্ন করেছে Poisson distribution. This is also Poisson distribution. What is the standard deviation distance? What is the probability the first major crack occurs between 12 and 15? It's exponential distribution. No major cracks in 2 separate 5 miles stretches. Binomial distribution. Okay, I think I get the hang of it. So basically, close the current tab. Use this tab also. So basically, practice করতে হবে। Okay, ঠিক আছে সবাই?
Yes, sir.
রোজার ভিতরে রোজা রেখে তোমাদের সবার ফ্যামিলি ভালো আছে? কারো কোনো ফ্যামিলি সমস্যা? একজনের আছে জানি, সেটা চলে গেছে। কারো সবার ফ্যামিলি ভালো আছে? Anyone having problem in the family?
Alhamdulillah, sir.
Alhamdulillah, great. Great. My family is also, alhamdulillah, fine. Okay, so this ends this chapter. Let me introduce our next lecture. Sampling and estimation. The following topic will be covered: sampling, estimation, 2 modules. One has to do, in fact, 3 modules: sampling, central limit theorem, and interval estimation. Introduction. 2 types of statistics. At the start of the semester, there are 2 types of statistics: descriptive and it works on sample to find the mean, median, mode, variance, etc. And inferential statistics connects the properties of a sample to the properties of the population. Earlier, we have learned descriptive statistics, how to work with mean and all these things. And then we also talked about the properties of samples, like discrete distribution and continuous distribution. In this lecture, we will connect all these things. And once a sample has been taken and the properties of sample has been found, how do we connect the properties of the sample to the properties of the population? So estimate statistics of the population. So this is what we have. We have a population whose mean is mean is mu, variance is sigma square, and we may know these or we may not know this, but the problem is that we need to find the properties of population. Properties of population. Okay, of population. Therefore, what we have done is that we have taken a sample. We have taken a sample whose mean is x bar and the variance is s square. We take a sample, compute the statistics of the sample, find the mean x bar and s square. Then what is the relationship between the mean of the sample with the mean of the population? This is what we are going to talk about in this lecture. Point estimation and interval estimation. To compute the sample mean, let me talk about what is meant by point estimation. We have found the sample mean x bar and we have found the variance s square. We are going to concentrate on x bar. We are not going to talk about the variance. So let's just concentrate on the mean x bar. So based on this sample, if someone asks us, what is the mean of the population? Rather, what is the mean? Okay. Essentially, what they're asking for is one number. Asking for one number. Okay. This is called point estimation. This is called point estimation. But now that your knowledge about statistics is more than the knowledge of a normal person, if you think about it, and if you think about it, that if you actually find the mean of the population, okay, if you actually find the mean of the population, whatever number has been given, what is the probability that you will actually find this mean that has been given? The answer is 0. Okay, because this mean will most likely be continuous distribution, and the probability that value in a continuous distribution is one particular value is always 0. Therefore, we will be asking for interval estimation in a more professional sense, that I will ask for two means, mu1 and mu2, and I will say something like that, that I am 90% sure that population mean is in this range. This will be referred to as interval estimation. We are going to talk about all these things. So to compute the mean, let's take this one step at a time. What we have done is that we have taken n elements from the population. We have taken one sample, okay, sample of size n, sample mean, sample size n. Sample size n. Therefore, what we have done is that we have taken n individual elements from the population. Like, let's say, for example, what is the weight of 18 to 24-year-old men of Bangladesh? Okay, population is too large. 18 to 24 years old, population is too large. Let's say we have taken 1,000 samples. One sample, size n equal to 1,000. Therefore, the way we are proceeding is that we have taken 1, 2, 3, n equal to 1,000 elements from the population. Okay, to compute the mean, this is what I have done. I've added all these elements and divided by n, and that has given me n. Go ahead and compute the expected value of x bar and variance of x bar, meaning that if I'm a little bit theoretical here, that before embarking upon finding the mean of the population, I take this one particular element and ask that, what can I get? What am I expecting? As I'm taking this x1, before taking the weight of this person, this boy, this man, you're asking how much can I get? That is the expected value of x bar. And the way we are going to do this is we take the expected value on both sides. Expected value of both sides of this expression. Things will look a little bit theoretical at the beginning, but at the end, things will become very straightforward. So we take expected value on both sides. Now the expected value of each one of them is the mean of the population. Expected value of x1, expected value of x2, and xn. That is the mean. So mean. So this is the critical and interesting thing, that similarly the variance of the x bar will be sigma square by n. These are point estimates of x bar and sigma square. What do x bar and variance of x bar mean? Recall that x bar is the mean. Okay, recall that x bar is the mean of the sample, and also written as ex. Therefore, ex can be referred to as expected value of. Let me actually go back. Expected value of x bar is equal to mean. Let's actually elaborate on that. I have a population. Mean is x bar. Mean is, sorry, mu. And to compute mean or to estimate mean, I've taken a sample. I've taken a sample, and we want to find the mean x bar. Before finding x bar, we're asking, what can I expect? X bar, we ask, what do we expect? Okay, before finding x bar, we are asking what do we expect. Okay, well, interesting thing is that answer is mu. That I can get, most likely I will get the mean of the population. So expected value of x bar is expected to be the mean of the population. And similarly, the expected value, the variance of x bar is the mean, is sigma squared by n. But now, what does expected value of x bar and variance of x bar mean? Now, x bar is mean. Mean of sample. Okay. Ex is mean. Therefore, Ex bar, then it means that this is mean of the means. Yes, what does it mean? I'm coming to that. Mean of the means. Expected value of the means or mean of the means. So what does it mean? Similarly, variance of x bar refers to as variance of, this is what is happening. Let me clean this. This is what is happening. If a population with a mean mu, we have taken one sample and we want to estimate the mean that we want to estimate. To estimate mean, we have taken several samples from the population. Normally what we will do, we will take several samples. First sample, the mean is x1 bar. Second sample, mean is x2 bar. Similarly, x3 bar, x4 bar, and similarly, nth sample has given us xn bar. Okay. Expected value of x bar refers to as the mean of these means, that the mean of x1, 2, 3, 4 till n. When I take the mean of these means, I get expected value of x bar. The quantitative variance of x bar refers to as the variance of these means. These are also numbers, remember. That these are also numbers. Some numbers, x1 bar, x2 bar, 3, 4, and till n. We have seen expected value of x bar to be mu and variance of x bar to be sigma squared by n. To put things in perspective, we are attempting to estimate the mean of the population mu. Based on the information we have so far, if we are asked to estimate mu, we will reply Ex bar. Whatever mean that we have found, mean of the means that we have found, that will be our answer. If we are asked to estimate sigma square, we will reply n times variance of x bar, are called point estimators, as I was mentioning earlier. In reality, if we actually compute mu and sigma square, how confident are we that we would get Ex bar and n times variance of x bar? Unfortunately, the answer is 0. Okay, because these will be continuous distribution, and probability that in continuous distribution that we get a particular value is always 0. We have a dilemma. We have an estimate. Unfortunately, we are not confident about the estimate. So we would like to estimate a range mu1, mu2 based on the confidence. As an example, we would like to say that we are 95% sure that the mean of the population will be between mu1 and mu2. Okay, we end here. This was just a basic foundation. আমরা এখানে যা শিখেছি এটা নিয়ে, এটার উপর বেসিক্যালি কোনো অঙ্ক হবে না, কিন্তু এটার উপর বেস করে আমরা নেক্সট ক্লাসে আমরা কিছু জিনিস আমরা দেখব, এবং সেখান থেকে আমরা we will actually learn যে এস্টিমেটটা আমরা কিভাবে করব. That I want to be 90% sure what is the estimate. I want to be 95% sure what is the estimate. I want to be 99% sure what is the estimate, so on and so forth. So just ask a foundation টা তৈরি করলাম. Okay? So foundation টা তৈরি করলাম, এটার উপর বেস করে আমরা নেক্সট ক্লাসে আমরা দেখব যে কিভাবে আমরা এস্টিমেট আমরা বের করব. Okay? I have started to correct scripts or give you feedbacks. I don't want to show that there are a lot of zeros on this. So just wanted to show you that I've started doing this, and hopefully within this weekend I will finish everything, and next week I'll give you all the feedback that you would be looking at. Okay. Fayaz Shibli, Farhan Ishraq,
Present, sir. Present. Fire ship present, sir.
Shamrat Khan, Amarul Islam,
Present, sir.
Maruf Ahmad,
Present, sir.
Shams Noor,
Present, sir.
Ishtiaq Ahmad,
Yes, sir.
Noor Manik, Yasir Arafat, Noor Kainat,
Present, sir.
Ishraq Zuhair, Mahfouza Khanam, and Samreen Chaudhary. Samreen Chaudhary is present. Okay. Thank you very much. I will see all of you on Sunday. All right? Thank you.